So I'm going to go over a couple problems from the homework from 17, the related rates problem. One of the problems I'm going to go over is question number 31. So the question says, a balloon being filled with a helium at a rate of 4 cubic feet per minute. The rate in square feet per minute at which the surface area is increasing when the volume is 32 pi over 3 cubic feet. So basically you're given the change in volume over change in time, or cubic feet per minute. You're told the actual volume, and you're being asked for the change in surface area, and they said in square feet per minute, but essentially they're asking for the rate at the change of the surface area. Okay, so we need to kind of think of, well, there's a few ways to do this. And I was kind of thinking what maybe an easy way to do this would be to do the volume and surface area separately, because it's a little bit complicated to connect the surface area to the volume. We can, and it can be done, but there's a little bit of a easy out if we do it a different way. So first of all, that's the first thing we think. Oh, we need surface area, we need equation for surface area, we need equation for volume. So I'm gonna go volume is equal to, for a sphere, is 4 pi r cubed. The surface area for for a sphere is 4 pi r squared. Okay, so the problem is neither of these relationships connects area to volume. Okay, but we could connect them through, I don't know what happened there. I'm just gonna undo all that there. So what we can do though is see that they are connected through the radius. Okay, those relationships are connected through the radius. So what we can do then is we can kind of do this problem through the radius. So what I'm going to do is I need to figure out what the radius is. Okay, before I do this, well, I'm going to differentiate first. So I'll differentiate this first. I get dv over dt is equal to 4 pi r squared. I'm not exactly sure what's happening in my video here. It keeps on jumping around on me. Okay, and then the derivative of the surface area, this is what we're looking for, the dA by dt is going to be 8 pi, oops, sorry, I forgot to multiply, that's an embedded function, so I need to apply chain rule. This one's going to be 8 pi r, and again, this is chain rule here. Okay, so right now I have dv by dt, I don't know r, I don't know dr by dt. But what I could do is I can use the volume to work out the radius. If I know the volume of the sphere, I can work out the radius. So I'm going to do this. So 32 pi over 3 is equal to 4 over 3 pi r cubed. And I can solve that equation for r. I can figure out at this volume what is the radius. Okay, so I can simplify, cancel a few things out. I end up with 32 equals 4r cubed. R cubed equals 8. R is equal to 2. Okay, so that's my radius that I need. Well, if I take a look at this equation, I have dv by dt, I have r, I can work out dr by dt. I want to solve for the change in surface area over change in time. I know r, and if I can work out dr by dt, I can figure out dA by dt. So I'm going to, first of all, use this equation here. I'm just going to solve for dr by dt. So I'm going to plug in 4 cubic feet per minute is equal to 4 pi r squared times dr by dt. I want to find that rate. The change in the radius of the change in time is going to work out to be, pi's cancel out, sorry, the 4's cancel out, so I'm going to end up with 1 over 4 pi. That is my dr by dt. Well, knowing dr by dt and the radius, I'm going to be able to solve for dA by dt. So that's what I'm going to do down here. I'm going to take that dA by dt, 8 pi, and I know the radius is 2. I've calculated up there. Dr by dt, I'll do this in a different color so we can see where it came from. Dr by dt is 1 over 4 pi. Okay, canceling out the pi's. Okay, we have 16 divided by 4. That works out to be 4. Okay, so it's 4 square feet per minute is my rate of change.